Welcome to the deep dive.
Either.
Today we're zeroing in on counter unmanned aircraft systems, CUAS.
Right.
It's hard to miss how drones have just, well, exploded,
Mhm.
moved from being these hobbyist gadgets to really capable bits of tech.
Oh, absolutely. The leap's been huge.
And that leap in capability, it also means we need to think, seriously about protecting ourselves from potential misuse.
Hmm.
We're not just talking about flying them for fun anymore. These things can be, well, adapted for gathering intel, even carrying and delivering harmful stuff.
Yeah. Dangerous payloads. It's a real concern.
So, our mission in this deep dive is to really unpack CUAS technologies for you. We want to explore how they work, what challenges they're trying to overcome, and the ongoing efforts to make them even better.
That's right. And for this deep dive, we've pulled together, I think, a really insightful collection of sources. We'll be looking at info from the Department of Homeland Security's Science and Technology Directorate, DHS S&T, yeah, and the Department of Defense, the DoD. We're also tapping into perspectives from companies right in the thick of it, like Quickset Defense Technologies and Dedrone.
Industry views, good.
Yeah. Plus, we'll examine what that Nagorno-Karabakh conflict tells us about drone warfare.
Right, that was significant.
Very.
Yeah.
And even looking at the legal side of things, and the practicalities of safely handling drones you might capture.
Our aim then is to give you a clear, comprehensive understanding of the CUAS world, cut through the complex tech talk,
Hmm.
and really highlight the crucial insights. So you come away feeling, well, informed and definitely not left in jargon.
Likely.
Okay, let's get into it. The big question. Why is there such a focus on these counter drone systems right now? What's driving this need?
Well, like you said, it's the sheer increase in the number of small unmanned aircraft systems, SUAS, as we often call them,
Right, SUAS.
being sold. That, combined with their rapidly improving capabilities, has turned them into a significant security concern.
Just volume and capability.
Exactly. The DoD puts it very bluntly. These aren't just toys anymore. They've evolved into genuine hazards that could impact the joint force, military operations.
Okay.
The key thing for you, the listener, is that this isn't some hypothetical future risk. It's something the highest levels of defense are actively tackling right now.
It's that dual use aspect of SEAS that really stands out, doesn't it?
It really does.
I mean, on one hand, they're great, used for entertainment, inspecting infrastructure, helping law enforcement, firefighters, loads of good stuff.
Sure, lots of legitimate uses.
But then, like you said, the same technology can be turned around by malicious actors for harmful purposes. It's a real double-edged sword.
Precisely. I mean, think about the intelligence gathering potential alone.
Yeah.
Just stick a camera on one, and an adversary can get significant insights into sensitive locations, activities.
Yeah.
Gives them a real edge in understanding a situation.
And it goes beyond just looking, right?
Oh, far beyond surveillance. These systems can be adapted to deliver small, but potentially very dangerous payloads. We're talking conventional explosives, or, maybe more alarmingly, chemical, biological, radiological agents.
Wow. Okay, that's sobering.
That's a serious escalation of risk.
Yeah. Absolutely. And it's not just those direct threats, is it? Even the ability of SUAS to act as like force multipliers, extending an adversary's sensor range, their comms reach. That's a major concern too.
Definitely. It's like giving them eyes and ears much further out, lets them react faster, operate from safer distances.
So, with this clearly growing, evolving threat,
Mhm.
what are our government agencies actually doing to get ahead of the curve?
Well, the DHS S&T program, for instance, has very specific goals. Their main aim is advising on the performance of the latest CUAS tech,
Okay.
making sure DHS has a rapid response capability for immediate threats. And crucially, they're focused on taking promising tech through rigorous R&D, testing, evaluation.
The whole pipeline.
The whole pipeline, exactly, with the end goal of transitioning effective tools to the DHS components that need them most. The key insight, I think, is that focus on practical application, getting effective tech into the hands of frontline people quickly.
That sounds very proactive, results oriented. And it's good they're not operating in a vacuum, right? There's mention of collaboration.
Yeah, collaboration with the Department of Justice, DOJ, and the DoD to share test findings.
Smart. Avoids duplicating effort.
Exactly. Leverages collective expertise across agencies. And DHS S&T also had this broad call for innovation. Their long-range broad agency announcement.
What's that about?
It's basically an open invitation to establish tech companies, but also new non-traditional players.
Hmm.
Bring your CUAS ideas to the table.
Casting a wide net for solutions.
Precisely, exploring the widest possible range, not just sticking to the familiar.
And it looks like their efforts in FY23 were pretty significant, transitioning over 15 CUAS technologies to agencies like CBP, FPS, TSA, the Secret Service. That says a lot.
It does. Real impact.
Plus supporting operational events, tons of tech tests, and also looking at cybersecurity, spectrum use, evaluating different CUAS types, even updating privacy and safety docs. It seems really comprehensive.
It is. Now, if we pivot to the Department of Defense, their initial response was a bit different.
So,
They focused on rapidly deploying readily available solutions, material, to address the immediate need, which makes sense, but
that led to
it
problems.
led to a situation with multiple systems, often not integrated, sometimes redundant. They kind of realized, okay, we need a more unified strategic approach here.
So what was the turning point for DoD? How did they shift gears to, get a better handle on this?
They developed a comprehensive CSUAS strategy built around 3 core lines of effort: ready the force, training and equipping people;
Okay.
defend the force, developing and deploying effective defenses; and build a team, focusing on collaboration, partnerships, both inside DoD and with allies.
So a holistic strategy, not just tech.
Exactly. People, processes, partnerships too,
Mhm.
recognizing it's bigger than just the hardware.
And to drive that unified effort, they set up the Joint CSUAS office, the
Yeah.
JCO, right? That sounds like a critical step for coherence.
Absolutely critical. The Secretary of the Army was designated the lead, the executive agent for CSUAS,
Okay.
and the JCO became the central hub, leading, synchronizing, directing all CSUAS activities across the entire DoD.
What are their main goals then, the JCO?
Key strategic objectives are
Mm-hmm.
enhance the joint force through innovation, collaboration, develop both material and non-material solutions, so tech, but also doctrine, training,
Got it.
and build strong relationships with allies and partners.
Mm-hmm.
This is a shared global challenge, right? So presenting a united front against this evolving threat.
Okay, so now we understand why COAS are so crucial and what government's doing at a high level. Let's really get into the details now. How do these systems actually work, technically speaking? What are the key technologies, the methods they use to detect, track, identify, and ultimately neutralize threatening drones?
Okay, so at their core, CUAS systems operate through a series of steps. Think of it like a chain. Sense, understand, then act.
Okay.
The first step, detection, often uses a mix of different sensor types working together, like visual recognition systems, cameras, often boosted with AI.
AI comes into play early then.
Oh yeah. To identify specific drone models, maybe even the payloads they're carrying, like a sophisticated spotter that learns what different threats look like.
Okay, like having a really vigilant observer who doesn't just see something but knows what it is, but what happens after it's spotted, after detection.
Right, once a drone's detected and flagged as potentially threatening, the countermeasure tech kicks in. One common method is RF jamming, radio frequency jamming.
How does that work?
It disrupts the communication links between the drone and its operator on the ground. Break that link. And often the drone's programming takes over. It might trigger a return to home function or just force it to land as a safety default.
So you're not necessarily blowing it up.
Exactly. The key takeaway there is it's often non-kinetic. Prioritizing disruption over destruction helps minimize collateral damage,
Interesting. So cutting off instructions, what about GPS spoofing? That sounds, well, like spy stuff.
It does have that feel. GPS spoofing means sending out fake GPS signals stronger than the real ones the drone's picking up.
Tricking it.
Yeah, feeding it bogus location data. You trick its navigation system into thinking it's somewhere else.
Yeah.
Potentially letting you take control or at least guide it away from a protected area.
Wow. That's pretty clever. Getting control without firing a shot. But what if you do need a more direct approach? What if you need to physically stop it?
That's where physical interception methods come in. Things like launching nets.
Nets, like literally nets.
Literally nets, launched from the ground or even from other drones, interceptor drones designed to physically capture the target.
Okay.
There are also systems using projectiles to disable the drone. And then in more, say, advanced military settings, you might see directed energy weapons.
Like lasers.
Lasers, yeah, or high-powered microwaves, used to disrupt the drone's electronics or even cause structural damage.
Lasers and microwaves.
Oh.
Definitely sounds like cutting-edge stuff. Are those widely used or still more experimental?
Directed energy is, well, it's more common in military applications right now.
Right.
Still facing some challenges, power needs, effectiveness in different weather.
Right.
More broadly applicable, maybe, are techniques like cyber attacks, exploiting vulnerabilities in the drone software or comms.
Hacking the drone.
Basically, yeah.
Yeah.
Hacking it to gain control or just force it to shut down.
It sounds like a really diverse toolkit being developed. I remember reading DHS S&T has been testing both kinetic, the physical stuff, and non-kinetic capabilities.
Absolutely. Their kinetic testing looks at projectiles, nets, lasers, electromagnetic waves, how effective they are at stopping drones physically.
Okay.
But they're also heavily invested in non-kinetic stuff tech that can detect and counter entire swarms.
Swarms, right? That's a big one.
Huge. And also those dark drones, the ones designed to be RF silent, hard to pick up electronically.
And they worry about collateral effects too, right? With the
Um,
kinetic stuff.
Oh, absolutely. A key part of kinetic testing is evaluating potential collateral effects. Falling debris, for example. Safety is paramount. You have to stop the threat, but safely.
Makes total sense. You need to neutralize the threat effectively, but minimize harm. And it sounds like the consensus is no single technology is the magic answer, the silver bullet.
Exactly. That concept of a system of systems is really central,
Reading.
meaning integrating multiple detection and countermeasure types, creating a more robust, layered, reliable defense. You don't rely on just one thing.
Layered defense.
Precisely. And, as companies like Drone highlight, AI and machine learning are playing a huge role here. AI algorithms can continuously, autonomously analyze sensor data, interrogate drone activity, filter out false alarms, and focus human attention on the real threats.
Now, dealing with one rogue drone is tough enough. What about countering threats over large areas or dealing with coordinated swarms of drones? That seems like a much bigger challenge, logistically, technologically, financially too, I imagine.
It certainly is a more complex challenge, yeah. For cost-effectively countering large swarms, things like high-power microwave weapons, HPM, and directed energy, DEWs, become pretty interesting.
Why them specifically?
Their potential to engage multiple targets relatively quickly, and maybe a lower cost per engagement compared to firing lots of missiles or nets. Electronic warfare, EW, is also crucial for disrupting communication and coordination within a swarm.
Breaking their teamwork.
Exactly. And, like we touched on, AI-driven autonomous defense systems could offer a scalable, rapid response with less direct human input needed for every single drone.
So the focus shifts to tech with broader effects, handling multiple targets without breaking the bank. What about scaling CUAS to protect, say, large areas of critical infrastructure? How do you go beyond just defending one spot?
The strategies there rely on layered and networked approaches, integrating passive detection sensors that don't emit signals themselves, deploying distributed sensor networks, maybe leveraging existing infrastructure like cell towers, using AI-driven threat analysis to allocate resources smartly, focus on the highest probability threats.
Being efficient with your defenses.
Right. And again, cost-effective mitigation like EW and D2Ws are important for wide area coverage. The emphasis is also on making CUAS solutions interoperable and modular.
So you can scale them up or adapt them?
Exactly. Scale incrementally, adapt as the threat changes or as resources allow.
Let's delve a bit deeper into that processing chain you mentioned, how a system goes from first seeing something to neutralizing it. Can you walk us through those stages again? Detection, tracking.
Sure. The CUAS processing chain is that framework. Detection, tracking, identification, and mitigation. 4 key stages, usually sequential.
Okay.
First, and absolutely critical, is detection, using various sensors to just sense something is there in the airspace.
And what are the main sensors used for that initial detection?
Well, you've got radar systems, active radio waves, bouncing off objects, giving you range, bearing, altitude.
Standard range.
Right. Then there's passive RF sensing, listening for the radio signals between a drone and its ground controller. Detects and might identify without emitting anything itself.
Stealthy detection.
Kinda, yeah. Then EOIR cameras, electro-optical, infrared. They provide the visual confirmation. The eyes on, often directed by alerts from radar or RF.
So one sensor cues another.
Often, yes.
Mm-hmm.
And finally, acoustic sensors. Listening for the drone's sound signature can be useful in quiet, remote areas.
So it sounds like each sensor type has its pros and cons. Range, weather, what info it gives.
Precisely. Radar can see far, but might miss tiny drones or low flyers. Passive RF needs those control signals to be active. EOIR gives you that visual ID, but fog, smoke, darkness can limit it.
And acoustic.
Acoustic sensors are great in quiet places, but shorter range and easily drowned out by background noise, wind, traffic.
So once a drone is detected, tracked. Next is identification. How do systems figure out if it's actually a threat versus, I don't know, a bird or a friendly plane?
Identification often involves analyzing the specific characteristics of the signal, or the visual signature, comparing that data against databases of known drone models, their typical flight patterns, behaviors.
AI again.
AI and machine learning are huge here. Learning patterns, differentiating friend from foe, even spotting suspicious payloads.
And then comes mitigation, taking action. We touched on these, but maybe a bit more detail. RF jamming.
Right. RF and GNSS jamming global navigation satellite system, like GPS. Disrupt comms or navigation signals. Causes the drone to hover, land, or maybe return to home.
Can you focus the jamming?
Yeah, jamming systems can be directional, aimed at one drone, or omnidirectional, affecting a wider area. Spoofing, as we said, sends false navigation signals. Cyber attacks exploit vulnerabilities to take control or disrupt.
And the kinetic options.
Kinetic methods are the physical ones. Net guns, projectiles, high-power lasers, or even high-power microwaves to fry the electronics.
You even mentioned trained animals earlier, which was unexpected.
Huh? Yeah, that's definitely a niche solution. More for very specific controlled environments. Probably not large-scale deployment.
Right.
Now, shifting focus. I think looking at real-world drone warfare is incredibly valuable. The second Nagorno-Karabakh war in 2020. That really stands out.
It absolutely does. Many analysts called it a watershed moment, maybe the first major war where unmanned systems were truly dominant. The Turkish Bayraktar TB2s, those Israeli AROP loitering munitions used by Azerbaijan, they were key.
Several really crucial lessons came out of that. First, the critical importance of well-trained people to operate and maintain these advanced UAS.
The human element.
Absolutely. Azerbaijan, with Turkey's help, had invested heavily in training. Armenia was caught, well, largely unprepared on that front. Second, it showed how important a good plan and seizing the initiative early are. Azerbaijan's proactive, sustained drone offensive gave them a huge advantage.
Makes sense. Skilled operators, clear strategy fundamentals for any military tech. What else did we learn?
The war clearly showed how precision fires, mainly from UAS, but also artillery guided by drone recon enable ground maneuver. A lot of Armenia's losses happened before ground forces even engaged due to these standoff attacks.
So drones paved the way for the ground troops.
Effectively, yes. Plus, the widespread use of UAV sensors made the battlefield incredibly transparent. Azerbaijan had this near-constant real-time view of Armenian positions. Traditional camouflage, pretty much useless against DOIR cameras.
That idea of a transparent battle space, it must fundamentally change tactics.
It really does. Which leads to another key takeaway. The need for masking.
Masking, not just camouflage.
Right. Camouflage alone isn't enough now.
Yeah.
Masking means using a whole spectrum of measures, active and passive, to make your systems hard to detect and target across all sensor types. Confusing, disrupting, jamming, deceiving the enemy's sensors and networks.
So it's not just hiding visually, it's actively denying their ability to see you electronically, thermally. That's a big shift in thinking about survival.
A huge shift.
But were there any limits shown? Were drones completely unstoppable in that conflict?
Not entirely. Analysis suggests things like bad weather,
Weather, right.
which can ground drones or limit their sensors, and effective CUAS capabilities could have significantly changed things. In Nagorno-Karabakh, the weather was mostly good for drones, and Armenia's air defenses and their few Russian CUAS systems were largely ineffective against the onslaught.
So it showed the power, but also potential vulnerabilities if you have the right counters or the environment isn't cooperating.
Exactly. It highlighted both sides of the coin.
Now, with all this advanced tech and evolving strategy, we have to talk about the legal side. The framework around CUAS. I know there are some pretty big restrictions on who can actually use these systems.
That's a critically important point, yeah. In the U.S., federal law generally prohibits most people and entities from operating many CUAS technologies.
Prohibits. So who can use them?
Currently, only a few federal departments have explicit legal authority to take actions that might otherwise break those laws. Specifically, Homeland Security, DHS, Justice, DOJ, Defense, DOD, and Energy, DOE.
Just those four.
Primarily, yes. That highlights how complex the legal landscape is here.
So for everyone else, other federal agencies, state, local, tribal governments, private companies, there could be major legal hurdles to even buying or using CUAS.
Very significant limitations, potentially. It sounds like getting solid legal advice is absolutely essential before even thinking about deploying anything.
That seems wise.
Absolutely. Legal experts strongly recommend, before anyone even considers testing, buying, installing, or using any CUAS system, get legal counsel. specifically experts in federal and state criminal law, surveillance law, communications law.
It's not simple.
No, it's not just about labeling a system active or passive.
Mm.
Legality often depends on the specific function and potential impact of each system. Very nuanced.
What about the specific authorities DHS does have? What are they legally allowed to do against unlawful drones?
Authorized DHS components have a range of specific authorities for protecting designated facilities and assets. They can legally detect, identify, monitor, track UAS in those areas.
Okay.
They can issue warnings to the operator, disrupt the control link, seize or take control of the aircraft.
Seize it. Wow.
Yeah. And even use reasonable force, if needed, to disable, damage, or destroy a threatening drone.
Those sound like pretty broad powers. Are there limits, conditions?
Yes, definitely. These actions are very specifically tied to defined DHS missions. Certain protection and security missions by agencies like the Coast Guard, CBP, Secret Service, Federal Protective Service.
Okay.
And they also cover authorized joint ops between DHS and DOJ, like security for big events, national special security events, supporting law enforcement at specific mass gatherings, or during active federal investigations in defined locations for limited times.
Got it. What about privacy? You're potentially intercepting communications. What safeguards are there?
That's crucial. Federal law mandates that any interception or access of communications to or from a UAS must be consistent with First and Fourth Amendment protections and other surveillance laws.
Okay.
It can only be done in direct support of an authorized CUAS operation. And generally, records of intercepted comms have to be deleted after 180 days, unless they're needed for ongoing security investigations or potential prosecutions.
And who gets to see this intercepted data?
Very strict rules on disclosure outside authorized personnel within DHS and DOJ.
It sounds like a carefully balanced legal framework then, trying to address real security threats while protecting civil liberties and privacy.
That's the aim, yes. A difficult balance to strike.
Now, shifting to a more practical level, what happens when a drone is actually captured or recovered? I know DHS S&T developed an interesting tool for this, the Shake app.
Yes, the Safe Handling and Collection of Electronics app, Shake. It's a really practical development. CBP, Customs and Border Protection, for instance, they find drones used for drug smuggling quite often. When these drones are confiscated, there weren't always standard safe procedures for agents to approach and secure them. You risk your own safety or maybe accidentally compromising valuable electronic or biometric evidence on the device.
That makes complete sense. You don't want to trigger something nasty or wipe data that could be key intel. So what does Shake actually do?
It's a mobile app, downloadable, gives CBP agents, other authorized folks, crucial info and step-by-step guides for safely collecting non-operational or abandoned drones they find.
In the field.
Right in the field, and then securely getting them to a CBP site for deeper analysis. The main goal is exploiting the intelligence on those devices.
What kind of intel?
Well, the info can significantly enhance air domain awareness, provide insights to inform ongoing CUAS development, help understand how bad guys are modifying and using these drones.
So it's not just grabbing the drone, it's grabbing the data. What specific features does the app offer users?
A range of practical things. Visual ID tools for common commercial drones, a library of basic tech info on them, standard procedures for securing the area around a found drone,
Okay.
the ability to document it thoroughly using their phone camera, securely transmit a report, step-by-step instructions for safely approaching and stabilizing the drone.
Stabilizing it, like making sure it doesn't suddenly power up.
Exactly, or making sure any payload is secure.
Yeah.
And even guidance on packaging and shipping it to the right analysis facility with contact info. There are also plans to maybe expand it for other electronic devices later.
Sounds like a really valuable, practical tool for a real-world challenge agents face. Finally, I wanted to touch on the team needed for effective CUAS. It's clearly not just about the tech. You need the right people with specialized skills, don't you?
Absolutely. Successful CUAS development, deployment, operation.
Yeah.
It demands a truly multidisciplinary team.
Like who? What roles?
You need skilled systems integration engineers, making sure all the hardware and software pieces work together smoothly. AI, machine learning, data analytics specialists developing the smart algorithms for detection, sensor fusion, threat analysis.
The brains behind the operation.
In a way, yes. Then, cybersecurity and electronic warfare experts assessing vulnerabilities, developing jamming, spoofing techniques, understanding the spectrum. Human-machine interface designers creating intuitive interfaces so operators can manage these complex systems under pressure.
Making it usable.
Crucial. And finally, operational logistics and sustainment technologists handling deployment, maintenance, lifecycle support, integrating it all into military frameworks like DOT MLPF.
It sounds like building and keeping these teams requires a huge range of expertise, technical and operational. What makes a CUAS system itself truly deployable and effective in the real world?
Key characteristics. Mobility is huge. Can it be transported easily, set up quickly anywhere? Scalability is essential. Modular designs you can adapt for different missions, different threats. Right. And crucially, integration. Seamless integration with existing military comms networks, command and control systems. It has to play well with others for joint operations.
And what about the people working in this field? What kind of skills and mindset do they need to be effective innovators, operators?
You need a strong technical foundation, obviously, advanced engineering, AML, EW, sensor integration, but also hands-on operational experience is incredibly valuable. Military logistics, deployment, understanding doctrine.
Book smarts and street smarts, kind of?
Kind of, yeah. Beyond the core tech skills, you need strong problem-solving, creative thinking, innovation, ability to rapidly prototype and test things, excellent collaboration and communication skills working across diverse teams, and fundamentally a commitment to continuous learning. This field changes fast. You have to adapt.
This has been a truly fascinating, really in-depth exploration into the complex world of counter-unmanned aircraft systems. So, to quickly summarize some key takeaways for you, the listener, we've seen how the rapidly evolving drone threat drives this urgent need for countermeasures. We've looked at the multifaceted approaches, all the different detection and mitigation technologies. We've touched on the critical strategic, tactical lessons learned from recent conflicts where drones were major players, and the ongoing efforts in government and industry to develop effective, legally sound CUAS solutions.
It's definitely complex.
It really is. A dynamic landscape, technology, operations, law, all intertwined.
Indeed. And it's a landscape that's constantly shifting. Both drone tech and counter-drone tech are advancing at a remarkable pace.
Which brings us to our final thought-provoking question for you, our listener. Given these incredibly rapid advancements on both sides of the equation, drone capabilities and counter-drone methods, what future innovations do you think will have the most significant impact on this ongoing security challenge in the coming years? And, maybe just as importantly, what broader ethical and societal considerations might arise as these technologies get even more sophisticated, more autonomous, and more widely deployed?
Lots to think about there.
It certainly is. Thank you for joining us for this deep dive.